Every time Google drops a hint about a new Gemini model, the internet loses its collective mind for about 48 hours. We get flooded with theories, leaked code fragments, and panic about superintelligence. Then the dust settles, and nobody actually separates the confirmed engineering facts from the pure hype. But if you ignore the noise and look at Google's actual development trajectory over the last 2 years, a specific pattern emerges. They are shipping major updates at a relentless, measurable pace. This chart plots Google's major model releases. Starting with Gemini 1.0 in December 2023, they jumped to a million token context window with 1.5, then integrated deeper search with 2.5 Pro. Reaching 3.1 Pro proved they reliably ship system upgrades every 6 to 8 months. Gemini 3 Pro is where the capability curve spiked. It scored nearly 92% on the GPQA Diamond test, a benchmark measuring expert-level physics and biology, and managed over 37% on an assessment called Humanity's Last Exam. DeepMind leadership refused to package these results as a standard software update. They framed the release internally and publicly as deliberate progress towards artificial general intelligence. That is not casual PR when you operate one of the top research labs in the world. Following this 6 to 8 month engineering cadence, we can pinpoint late 2026 as the launch window for Gemini 4. We are months away from deployment, requiring us to look directly at what is confirmed in their codebase. To figure out what Gemini 4 will actually do, we have to drop the internet rumors and decode the exact architecture and tools Google DeepMind is testing right now. At Google headquarters, engineers are already integrating Gemini 4's confirmed capabilities into their production developer API. The most crucial update verified by Google is Project Mariner. This integration pulls the AI out of the chat window and gives it direct, autonomous access to a web browser. This means Gemini 4 ships with full computer use built in. It can autonomously navigate websites, fill out complex forms, and execute multi-step tasks across different applications without asking for human intervention. It powers these actions through native multimodal fusion. Instead of processing a video, translating it to text, and then analyzing the text, Gemini processes audio, visual, and text data simultaneously in a single, unified reasoning loop. And through the underlying technology of their Gemma open models, Google is compressing the system to run locally. We expect a version of these agentic capabilities, Gemini Nano, to operate entirely on Android devices, like the Pixel phone, bypassing cloud servers and executing commands directly on your hardware. Add up the verified features and the engineering points to a clear transition. Gemini 4 is shifting AI from a tool that answers your questions into an autonomous system that takes control of your interface to do the work for you. But exactly how Google achieves the speed required for those tasks is heavily debated. Analysts are split over whether Gemini 4 will rely on dense model efficiency or scale up into a massive, sparse mixture of experts architecture. This diagram shows how a mixture of experts works. Instead of running a query through a trillion parameters all at once, the system routes your prompt to specific, smaller expert clusters. Then, this efficiency allows the AI to ingest massive data, pushing the short-term memory into the multi-million token range. A window that large allows the AI to ingest the data of an entire legal archive or corporate codebase in a single prompt. For comparison, OpenAI's GPT-4o tops out around 128,000 tokens. Claude 3 offers extensions up to 1 million. If Gemini 4 hits 2 million tokens or beyond, it leaves the competition behind on raw data capacity. Right now, Claude excels at careful reasoning. Google's strategic objective with Gemini 4 is to catch up to Claude's logic scores while leveraging their lead in context length and baked-in computer use. If these architectural rumors hold true, Google establishes a technical lead in long context processing that forces a reactive move from every major competitor. Giving an AI the ability to reason and control web browsers introduces new threats. On the ARC-AGI-2 benchmark, a test designed to measure novel problem-solving rather than memorize data, Gemini 3 hit 45.1%. Surpassing that 45% threshold suggests the model is developing emergent reasoning abilities. Google is aware of the risk. Their safety reports detail intense reinforcement learning with human feedback and internal red teaming to stress test the model for vulnerabilities before Gemini 4 ships. Because when a model is capable enough to navigate the web on its own, it is also capable of writing mutating malware that evades defenses, or generating localized, mass-scale disinformation campaigns with zero human oversight. Regulators are working to build containment structures. The European Union's AI Act is attempting to categorize and restrict these frontier models based on their potential for systemic risk. Organizations like the UK's AI Safety Institute, established following global summits at locations like Bletchley Park, are demanding external audits to verify exactly what these models are capable of before they reach the public. In the US, White House executive orders are targeting the potential misuse of advanced models for state-sponsored espionage and sophisticated social engineering. But the engineering cycles behind Gemini 4 move faster than the policy frameworks designed to govern them. The deployment of these features moves the system beyond standard chatbot interactions and into autonomous computer control. We are handing over the keyboard and letting the model manage the interface, forcing a total reimagining of AI liability, safety, and the definition of intelligence.